The year is 452 AD. The Roman Empire is collapsing, and the Huns are violently sweeping through northern Italy. To survive, thousands of locals made a desperate gamble. They abandoned their ruined cities and fled to a cluster of small, isolated islands scattered just off the coast. But this lagoon offered almost nothing. There were no roads, no fresh water, and the ground was made of a soft, marshy clay that could barely hold the weight of a person, let alone a permanent settlement. Yet somehow, those refugees took this hostile, muddy swamp and transformed it into the wealthiest, most powerful commercial hub in Europe, Venice. Survival in this environment required the invention of an entirely new method of engineering, designed specifically for a landscape that should have been uninhabitable. The first major hurdle the Venetians faced was the ground itself. You can't build heavy structures on unstable mud without them sinking. To create a solid foundation, engineers hammered massive timber piles from Croatia 5 meters deep into hard clay. Packing them closely compressed the clay, squeezing out water for a rock-solid base. Sealed from air, the wood was perfectly preserved from rotting. Once the foundations were set, they had to construct the city itself. After several devastating fires, they switched from wooden houses to brick. But to keep the weight manageable, buildings were strictly limited to a maximum of 3 stories. Because the ground was still prone to shifting, the architecture had to adapt. In this schematic, builders used flexible lime mortar and constructed inner walls in a crisscross pattern. This allowed the entire structure to sway slightly without cracking. But there was a catch. The outer facades featured elegant stone designs and large windows, making them incredibly heavy. To keep these massive walls from peeling away and collapsing, iron rods were driven right through the floors to pin the entire building together. With the foundation problem solved, the Venetians had a safe, repeatable way to build. Slowly, these scattered island settlements began to expand outward, merging toward one another. In the early days, crossing between these growing land masses was primitive. You either took a small boat or simply waded through the shallow water on horseback. But as the population boomed and trade accelerated, this casual transit wasn't enough. The growing city needed a fast, reliable way for merchants to reach Rialto, the financial center of Venice. First, a simple pontoon bridge, then a wooden structure, which kept burning down. Finally, massive stone marvels. Building these bridges required staggering resources. To construct the main artery across the central canal, engineers drove 12,000 timber piles into the banks just to support the 10,000 tons of stone required for the bridge itself. As more stone bridges went up, the city made a crucial decision. They would rely entirely on canals instead of paved roads. This created a highly efficient transit system. Heavy goods and commercial boats flowed smoothly through the water, completely separated from the pedestrians walking above. By replacing traditional streets with waterways, Venice eliminated urban traffic. It had evolved from a scattered survival settlement into a streamlined, hyper-connected commercial empire. But this rapid growth triggered a new crisis. By the time the population hit 170,000, Venice was facing a severe shortage of fresh drinking water. They were entirely surrounded by ocean water, but absolutely all of it was salty and toxic to drink. Engineers solved this by turning every open square in the city into a massive hidden rainwater funnel. Beneath the surface, engineers dug out the square, lining it with waterproof clay. They filled the basin with sand and stones. Rainwater flowed from angled surface tiles and roof gutters into this basin, slowly filtering through the sand to pool cleanly in the center. This underground system successfully fed clean water to over 600 stone wellheads scattered across the city squares, keeping the massive population hydrated. Yet that sheer number of people created a terrifying final bottleneck. 170,000 citizens generate a massive amount of human waste, and without a way to dispose of it, the dense city would quickly poison itself. Initially, people just threw their waste out the window. But by the 16th century, Venice built a network of underground tunnels designed to collect raw waste directly from the buildings and channel it out toward the canals. The system's power source was the ocean. When the tide dropped, waste settled in the tunnels. When the tide forcefully rose twice a day, it flooded the tunnels, pulled the solid waste into the lagoon, and flushed the city with fresh, disinfecting seawater. Engineers prevented a disaster by taking the very environment that threatened them. heavy rains and surging tides, and turning it into an automated life support system. What started as a desperate escape to an uninhabitable swamp resulted in one of the most resilient cities in human history. The Venetians took impossible geography and weaponized it into an advantage. The deadly, sinking mud became an impenetrable fortress foundation. The flooded marshland became a frictionless highway for global trade, and the aggressive tides became an automated sanitation engine. Today, the modern city still relies on that exact same infrastructure. These ancient brick structures are sitting directly on the waterline, supported by a 1,000-year-old subterranean forest. But that doesn't mean the battle is over. Despite their brilliant engineering, Venice remains highly vulnerable, and the fight to hold back the rising lagoon continues to this day. Ultimately, Venice survives as a functioning example of adaptive engineering, where the most hostile elements of the landscape were successfully turned into the infrastructure required for a global